Right now, you can do something strange. You can take a thought that exists only inside your head and put it inside someone else's. A warning, a memory, a plan, a story. You do it so easily that it feels normal. But in other animals, communication seems to stop much sooner. A sound can mean danger. A gesture can mean come here. But human language became something different. It could describe what was not here, what happened yesterday, what might happen tomorrow. So, why did ancient humans start talking? Most people assume the answer is simple: bigger brains, better mouths, maybe one lucky sound that turned into the first word. But that is probably not how it happened. The real story may have started before speech itself, with gestures, shared attention, social pressure, and ancient humans who needed more than noise to survive together. Because the real question is not just when humans made sounds. It is when those sounds became meanings. And the answer may begin somewhere you would never expect, not in the mouth at all. The obvious answer is anatomy. Humans developed bigger brains, more complex vocal tracts, and a throat shaped differently from every other primate. That combination, the story goes, eventually produced language. It is a clean explanation. It is also incomplete. Chimpanzees have large brains, proportionally among the largest of any non-human animal. They have vocal cords. They can produce a range of sounds. Under training, they can learn signals and use some symbols. But they do not develop open-ended human language. No chimpanzee raised by humans, exposed to speech from birth, has learned to speak the way a human child speaks by age 3. The gap between what we can do and what they can do is not a matter of degree. It is a different kind of thing, entirely. Anatomy can explain the instrument. It cannot explain the reason humans began to play it. One piece of the anatomy story involves a small bone in the throat called the hyoid. In most mammals, the hyoid sits high in the throat, close to the skull. In humans, it sits much lower, a position that opens up a larger resonating chamber above the vocal cords and allows for a wider range of speech sounds. This arrangement helps humans produce the variety of vowels and consonants that spoken language uses. But speech is not the same as language. Sign languages are full languages. They have grammar, nuance, poetry, and argument, and no sound at all. So the descended larynx explains something about how humans speak. It does not explain why language began, or what it fundamentally is. What the descended larynx does reveal is that something was driving vocal change, and that the change was not free. The lower larynx is one reason humans are unusually vulnerable to choking, compared with many other mammals. In most species, the airway and the food passage are separated in a way that makes choking rare. In humans, they cross. Evolution does not accept that kind of trade-off without a significant return. Whatever pressure was pushing human vocalization toward greater complexity was strong enough to make a daily choking risk worth it. Researchers examining a Neanderthal hyoid bone found it was shaped remarkably like our own, suggesting Neanderthals may have had at least some of the physical capacity for complex vocalization. Whether that capacity was used for something resembling language remains genuinely unsettled. Then there is the gene. In the early 2000s, researchers studying a family with severe speech and language difficulties identified a gene associated with their condition. The gene was called FOXP2, and it quickly became known in popular science as the language gene. That label overstates it considerably. FOXP2 is not a gene for language itself. It is more accurately described as one part of the motor control machinery that speech depends on, involved in the fine, rapid coordination of tongue and mouth movements that spoken language requires. Mutations in the gene disrupt that coordination significantly. What surprised researchers was what came next. Analysis of ancient DNA from Neanderthal remains showed that Neanderthals carried the same version of FOXP2 found in modern humans, not the older version found in chimpanzees. Whatever role this gene plays in speech-related motor control, Neanderthals appear to have shared it. A related version of FOXP2 is also active in songbirds, where it appears to play a role in learning complex vocal sequences. Humans and songbirds are separated by enormous evolutionary distance, but both show that precise vocal learning depends on more than having a mouth. It depends on neural control, practice, and imitation, a pattern that seems to emerge under similar pressures across very different lineages. FOXP2 is not the language gene. It is something more interesting. one part of the biological scaffolding that makes learned, precise vocalization possible. And the fact that a version of it appears in species as different as humans and finches suggests that the machinery for vocal learning is something evolution has reached for more than once, when the conditions were right. This is where the story leaves the mouth and moves to the hands. Some researchers now argue that the voice was not where language began. The evidence for this is not obvious at first, but consider what happens when you watch someone speak. Their hands move, their face moves. Even people who have been blind from birth gesture when they talk, to listeners who cannot see them. Gesture and speech are not separate systems that happen to run in parallel. They are deeply integrated in the human brain, so linked that suppressing one affects the other. Now, consider what happens with great apes and manual sign systems. Chimpanzees and bonobos trained in gestural communication have demonstrated vocabularies and combinatory abilities that far exceed anything achieved through vocal training. For many researchers, this is not a coincidence. It suggests the primate brain was already wired for something closer to manual communication long before the vocal system developed to its current complexity. The mirror neuron system offers one proposed mechanism. These neurons, identified in macaque monkeys and studied in humans, appear to fire both when an individual performs an action and when they observe the same action in another. They create a kind of automatic internal mirroring, a way of modeling what another body is doing. Some researchers have proposed this system provided early scaffolding for imitation and gesture, though the connection to language remains actively debated. What is less debated is the developmental sequence in human children. Infants point before they speak. They engage in shared attention, looking at an object, then at a caregiver's face, then back at the object, months before their first words. This triangle, between self, other, and a shared focus, appears to be the foundation on which language is built. Pointing is worth pausing on, because it reveals something important about the gap. Chimpanzees point. But when researchers examine how and why, a consistent difference emerges. Chimpanzees point primarily to request, to indicate food or a direction. They point for themselves. Human children point to share. They point at a bird, not because they want the bird, but because they want another person to see the bird. They want to create a shared experience inside someone else's mind. The object matters less than the sharing of attention toward it. That distinction, pointing to get versus pointing to share, may be one of the most important differences between human communication and everything that came before it. It is not about anatomy. It is not about grammar. It is about the motivation to bring another mind into contact with your own experience of the world. Robin Dunbar, an anthropologist at Oxford, has argued that language evolved partly as a form of social bonding, what he calls vocal grooming. In primate groups, physical grooming maintains relationships and holds the group together. But grooming is limited. You can only groom one individual at a time. As human groups grew larger and more complex, something more efficient was needed. Language allowed social bonding to scale. One voice could reach many ears simultaneously, maintaining relationships, sharing information, holding a larger group together across time. This is not language as simple information transfer. It is language as the technology of cooperation, the tool that made large, coordinated, interdependent human groups possible in ways that no other species has replicated. The modern echo of all this is closer than it might seem. Watch yourself the next time you are on a phone call, unable to see the person you are speaking with. Your hands will still move. Your face will still shift through expressions no one can see. The gesture system and the vocal system do not run separately. They run together, so integrated that separating them requires conscious effort. Children still learn pointing before words. Adults still reach for gesture when words fail. When language breaks down under stress or exhaustion or unfamiliar vocabulary, the hands take over. The older channel is still running beneath the newer one. Language did not begin in the throat. It began in the need to share a world with another mind, to make what was visible to you visible to someone else, to make what you knew something that could survive your death by living inside another person. The voice was the amplifier, but the signal was already there. So what was the real breakthrough? Not the larynx descending, not the gene arriving in its modern form, not the first sound that anyone agreed to treat as a word. The breakthrough was the moment an ancient human looked at something, a danger, a path, a memory, And instead of responding to it alone, turned to another person and tried to make them see it too. That impulse is so ordinary now, it has become invisible. It began, as best we can tell, with a gesture, with a pointed finger and a shared glance, with two minds, briefly, holding the same thing. And from that beginning, every word ever spoken followed. So, why did ancient humans start talking? Not simply because the throat changed, not because one gene appeared, and not because someone made the first lucky sound. Language may have begun with something older than speech, the need to share a world with another mind, a pointed finger, a shared glance, a danger seen by one person but understood by many. The voice became the amplifier, but meaning came first. So here is the question. When words are not enough, do you use your hands, your face, or just a look? Leave your answer in the comments. If you want more ancient human stories like this, subscribe. There is a new one every week.